So this is question 5. We have to prove that these are congruent to each other. Well, we know that that angle there and that angle there are the same, so angles ACD is equal to angle BCE because they're vertically opposite. And now it tells us that C is the midpoint of AB, therefore the distance from there to there has to be the same as there to there because it's the midpoint. So we know that the line segment AC is the same as the line segment BC because C is midpoint. Well, we have an angle proven to be the same, we have a side proven to be the same, so we just need the angle CAD be the same as angle CBE, and they are because it tells us in the question that BE and AD are parallel to each other. Therefore, those lines are parallel. Therefore, line really is just an intercept of two parallel lines. Therefore, that line and those two angles there have to be alternate to each other because they're on opposite sides of the intercept and uh, they're equal to each other. Therefore, they're congruent by angle side angle. Well, distance here then from X to all the way up to Q dash is going to be 12. So from X, Q dash is equal to 12 because from there to there is 8 and from there to there is 4. And we know that X just to Q is 8. Okay, so the distance from X to Q dash uh, is 1.5 more than X to Q. So if to get it from X to Q, you go 8, but then you multiply that by 1.5 to get to Q dash, so it's 12. Therefore, if we just do 12 divided by 8, it shows us the scale factor, so that's 1.5. Right, well, we know that the area of PQRS is 20. Therefore, if I want to know what um, the scaled, so the reflection of that or the enlargement of that, so P dash, Q dash, R dash, S dash, that has to be, it'll be 1.5 squared times 20. So that's how enlargements work when it's the area. And that would give us 48. Sorry, 45 that was. We also know then that from X to P there is 3. And we already knew that from X up to Q that was 8. So that whole thing was 8. So therefore, the bottom of well, from P to Q then has to be equal to 5. So it's that distance in there, that has to be 5. And the base times the height, that's how you get the area of any parallelogram. So if base times height is 20, well then 5 times something is 20. So the height then has to be 4. That's 5 times 4. That's base times height is equal to 20. And if we take, so just get rid of this for a second. If I take that from x to p is 3, but then if I was to do 3 multiplied by 1.5, that gives me 4.5. That means that the distance from x to p dash is 4.5. X to p dash is 4.5. So if x to p was just 3, well then the rest of it has to be 1.5. So that has to be 1.5 in there, p to p dash. So if that's 1.5, we can forget what the area this is in here. That would just be the base times the height. So that's just 1.5 times 4, because 4 is the height, and that gives us 6. So the area of SP yp dash, that's equal to 1.5 times 4, that's equal to 6. Therefore, if that area that I've just found out is equal to 6, we just have to take that away from the area of the whole parallelogram, because we know it told us in the question that the area of PQRS was 20. So we just have to do 20, take away 6, and it gives us 14. And that's the area of the shaded bit then. Didn't really need to have worked out that at all there.